What's up? Today we're going to talk about how to use the fundamental theorem of calculus to make our lives easier, to actually do function evaluations. Right, so we're given our derivative, and we have an initial condition, and we want to evaluate our original function at a different point. Okay, so I know what's happening at 2, I want to know what's happening at 3. Right, so we already know how to do this to an extent. Okay, what we could do is take the integral. So I know that y is equal to x cubed plus 2x squared minus 5x plus c. And I know that y of 2 is negative 1. So I could plug 2 in. I'll get 8 plus 8 minus 10 plus c. So that means that c is negative 7. So that means that y is as such. All right, so I just solved for c. And so I got my original function. Now I can plug in 3. And so if you plug in 3, you end up getting 23. Okay, so this is one way that I can do it. Okay, I can take the indefinite integral, I can solve for c using my initial condition, then I can plug in 3. Now the downside to this method is that very little of the work can be done in my calculator. And so if I have a difficult integral, then it's very labor intensive, okay, especially if I have a weird function. So another way I can do this is I can say, well, I know that the integral from 2 to 3, okay, so those are the two numbers that, I know what's happening at 2, I want to know what's happening at 3. Yeah, I know the integral from 2 to 3 of, I'm just going to say of y prime is equal to y of 3 minus y of 2. Okay, now I'm trying to figure out what y of 3 is. So I can get y of 3 by itself on this side of the equal sign by adding y of 2 over to the other side. And this is what I get. And this is something that I could input into my calculator if I wanted to. Right, now in this case, I don't have to. I can just do this. I know y of 2 is negative 1. I know this integral is x cubed plus 2x squared minus 5x. I'm evaluating from 2 to 3. Right, so I do the fundamental theorem. And so I end up getting 23. So same answer, except I could do this much quicker. I could do it in my calculator. It would take me all of like 30 seconds to do. All right, so we can practice that. So same thing here. We already talked about how to do these in our calculator. If you don't remember, you just hit alpha window 4, and then you input your integral as you need to. Okay, so here I know that the derivative is sine of x squared. I know what's happening at 1. I want to know what's happening at 2. Right, so I know that this is going to be f of 2 minus f of 1. Okay, I want to know what f of 2 is. So that means that f of 2 is equivalent to f of 1 plus the integral from 1 to 2 sine of x squared dx. Bad boy. I didn't put dx. Okay, dx. Now this is something I don't know how to do by hand. So I have to put this into my calculator. And so I end up getting negative 4.505 once I do. Okay, and again, if you don't remember how to do that, I'll just show you real quick. I go to my calculator. I hit alpha window 4 for integral, and then I can just input it into this form. Okay, now hypothetically, what if I wanted to find f of 1 instead? So from this step, what if I wanted to find f of 1? Well, again, I know that my integral from 1 to 2 sine of x squared was f of 2 minus f of 1. This time I want to get f of 1 by itself, so I could subtract f of 2 and multiply everything by negative 1, or I could add f of 1 over and subtract this. So I get f of 2 minus the integral from 1 to 2 sine of x squared. All right, easy enough. Let's keep going. Okay, so now I have a graph, and so this is the graph of f prime. And remember, every time I see that, I put that all over the place just to remind myself. Okay, this is f prime. Okay, I know an initial condition. I know f of negative 2 is 5. I want to know what f of 0 is. So I'm going to use this same idea. Okay, integral from negative 2 to 0 of f prime is going to be f of 0 minus f of negative 2. That means f of 0 is equal to f of negative 2 plus integral from negative 2 to 0 of f prime. Okay, so I can figure out what this integral is from my graph here. I know f of negative 2 is 5, and the integral from negative 2 to 0 is just this triangle right here. So it's this area. Okay, I have a triangle, base 2, height of 4, so the area is going to be 4. So my overall area is 9. Or sorry, my function at 0 is 9. Okay, now I want to figure out what's going on at 2. So I know that f of 2 is going to be f of negative 2 plus the integral from negative 2 to 2 of f prime. Alright, f of negative 2 is 5, and the integral from negative 2 to 2 is going to be this whole triangle. So this time my area is going to be 8, it's double, so I get an area of 13. Alright, last one, f of 6. Well, that's going to be f of negative 2 plus the integral from negative 2 to 6 of f prime. Alright, so again, that's going to be 5. Now I'm doing this whole thing, so that means negative 2, so this triangle, and then all the way to 6, so this semicircle. Now this semicircle is under the x-axis, so this is going to have an area of negative 2 pi, and this area we already found was 8. So plus 8 minus 2 pi, so 13 minus 2 pi. Right, and that is the value of my function at 6. Right, kind of complicated, but not too bad. Let's practice some more. Right, so again, this is f prime. Do it 3 times. All right, this area right here is 4. This area is negative 9 because it's under the x-axis. This area is 2. Same deal. Okay, I know what's going on at 3. So the integral from 0 to 3 of f prime is f of 3 minus f of 0. Okay, so this area from 0 to 3 is 4. I know f of 3 is 5. And I'm trying to find f of 0. So I can get f of 0 by itself. I get that f of 0 is 1. Okay. So let's get rid of some of this mess right here. Okay, so f of 7, so same deal. Taking the integral from 3 to 7, because 3 is the number that I know about. Okay, 3 to 7 of f prime. That's going to be f of 7 minus f of 3. Okay, now the integral from 3 to 7 is negative 9. I'm trying to figure out what's going on at f of 7. I know f of 3 is 5. That means that f of 7 is equal to negative 4. Alright, and last one. So I know that the integral from 3 to 9 of f prime is equal to f of 9 minus f of 3. The integral from 3 to 9 is going to be negative 9 plus 2, so negative 7. This is my unknown. F of 3 is 5. That means that f of 9 is going to be negative 2. Right, now I could use all this to try to sketch a graph. Right, so I know that initially at 3, I exist at 5, so I'm going to give myself 3, 4, 5, some tick marks there. Yeah, I'm going to give myself some down. 2, 3, 4, 5. Okay, so at 3, I know I'm at 5, so right here. Okay, I know that at 0, I'm at 1, and then I know that at 7, I am at negative 4. And then at 9, I'm at negative 2. All right, so I have kind of an idea here. And remember, this is your derivative graph, so this tells you where you're increasing and decreasing. Yeah, I'm increasing until 3, and I see that. So I'm going to go up to 3. That's the worst thing ever. I have to do that again. Okay, so I'm increasing until 3. Then I'm decreasing from 3 to 7, so that makes sense. So, zoop. And then I'm increasing from 7 to 9, so zoop. All right, not bad. All right, last example, and again, this is just some calculator practice. I'm given an initial condition here. So my pizza starts at 95 degrees. It's put in the room at 25 degrees when time is 0. The pizza's temperature is decreasing. I want to know what's happening at 5 minutes. So my initial temperature is 95. It's decreasing. it's decreasing for 5 minutes. So between 0 and 5 minutes, it's decreasing at a specific rate. I don't care what my rate is, but at a specific rate. I don't know how to do this integral, so I'm going to plug it into my calculator. Right? You can plug it in your calculator just like this. Obviously, you would not put r of t. You could put 6e to the negative 0.1 t dt. Put this in your calculator. You should get 71.391. You might want to check yourself on that. That's just calculator practice. All right, that's it for this one. See y'all later.